Hi guys, Mrs. Waymeyer here. We're going to be talking about powers of 10 today. So we're going to be multiplying and dividing them with whole numbers. Whenever we think about multiplying numbers together, we're thinking about getting a product, and our product is typically larger if we're multiplying. Along the side, you'll notice we're going to be talking about some patterns that we notice as well with our base of 10 because you're going to be seeing some patterns with our zeros and things as we work through some of these problems. So let's get started. In our first box, we have multiplication. So we're going to start with 5 times 1. 5 times 1 is 5. And then I notice I'm going 5 times 10. Well, to do our mental multiplication, we're going to take 5 times 1 first, which we said was 5, and add our 0. Another way you could think about this problem is we're taking 10 5 times. So 10 plus 10 plus 10 plus 10 plus 10 would get us 50. So going back to that repeated addition. 5 times 1 is 5, and then we're going to add 2 zeros to get 500. On this fourth problem here, 5 times 1 is 5, and then adding our 3 zeros to get 5,000. Some patterns are some things that you should be noticing. Each time it's increasing by a 0, it's adding a 0 to its answer, its product. Also, I hope you're noticing that when I'm taking it times 10, this factor has 1 0, so my product has 1 0. This factor has 2 zeros, so my product has 2 zeros. This factor has 3 zeros, so my product has 3 zeros. And that's going to kind of come into play when we start talking about our bases and our exponents, when we start doing powers of 10 here in just a moment. When we're thinking division, 5 divided by 1, well, what could we multiply by 1 to get 5? So turn it around to a multiplication problem. We're still going to end up with 5. This time we're taking 5 divided by 10. Well, whenever we have a whole number, our decimal is actually imaginary. So this 5 wholes is the same thing as this 5 wholes. Our decimal just happens to be invisible. So for this example, we're going to actually make our decimal visible. Since we're taking it divided by 10, when we're dividing the whole numbers, we should be getting a smaller answer. We should be dividing. So up here we got larger answers. Now we're dividing. In order to get this answer right here, I'm going to take and move my decimal back 1 decimal place and end up with 0.5. Another way you could think about this is 5 divided by 10. If I were to write that like a fraction, 5 divided by 10, we would end up with a half as well. So over here in this third problem, we have 5 divided by 100. Again, I'm going to make my decimal appear, and this time I need to move my decimal back, not 1 space, but 2 spaces. So 1, 2. So my answer, because I've moved it back 2 spaces and run out of digits, I need to add a 0 here. So my answer, let me erase that. My answer ends up being 0 and 5. So that answer ends up being 5 hundredths. This one up here ended up being 5 tenths. So if you're seeing that problem as I'm emphasizing that, here's my whole number. I'm going to take my decimal and move it backwards 3 spaces. 1, 2, 3. I need to add in 2 zeros, giving me the final answer of 5 thousandths. So hopefully you're noticing as I'm working those problems out, your decimal is moving to the left because our numbers are getting smaller, and 5 tenths, 5 hundredths, 5 thousandths. So our zeros are telling us how many spaces or how many place values to move backwards. So what if we change those to powers of 10? Remember, your base is your 10, and your exponent is telling you how many times you need to repeat times 10. So 10 to the first power really is just 10. 5 times 10 gets us 50. If we were to take 5 times 10 to the second power, this is really 10 times 10. 10 times 10 is 100. So 5 times 100 is 500. Excuse me, 10 to the third power is 1,000. So 5 times 10 to the third power would be 5,000. 5 times 10 to the fourth power would be 50,000. A pattern I'm hoping you're noticing here is that our exponent is actually telling us how many zeros to add. We started with the whole number 5, and we needed to add 1 0. Then we needed to add 2 zeros, 3 zeros, and 4 zeros. So I like working with bases of 10, powers of 10, because they make it a little bit easier. There's not as much math involved as far as adding zeros and just knowing about your place values. So let's do a couple of examples, more examples on the back. I'm not going to probably do them all, but just a couple for your reference. So if I were doing 23 times 100, I'm going to take 23 times 1 and add in my 2 zeros. 2,300. This time I'm taking 15 divided by 1,000. So remember, 15, we have an imaginary decimal here that we're going to make up here. And I'm going to move my decimal back 3 spaces to the left. 1, 2, 3. Because I've run out of digits, I'm going to add a 0, giving me the answer of 15 thousandths because I'm in the thousandths place. So that answer makes sense. 12 times 10 to the second power, adding in 2 zeros. If I were to take 26 divided by 100, here's 26, here's my decimal. I'm going to move it back 2 spaces. So it ends up giving me 26 hundredths. And lastly, let's do this one. 19 times 10 to the third power. So if I were to take it times 10 to the third power, 10 to the third power really is 10 times 10 times 10, not 30. It's 1,000. So 19 with 3 zeros, 19,000. So hopefully that helps you understand powers of 10 using multiplication and division. We'll talk about this a little bit more, but this is kind of a way to help you use mental math using your hundreds, tens, and thousands, and also using your bases of 10 to be able to multiply and divide mentally. Thanks for watching.